Thank you. So today I'm going to talk about delivery. I'll cover some common performance problems that can be really frustrating for users. I'll show you some optimizations that you can make to most any site to make it usable in a fraction of the time that it would otherwise take. So as web designers, I feel it's our job to build sites that respond to our users' needs, right? That's a fairly uncontroversial take on what we do. And I think that term respond is a nice way to describe what we do, but it also has a misleading tendency to sound sort of passive or reactive. And I think if you've built sites that work across many devices before, you know that that's hardly the case. The sites we build today need to respond to a variety of factors and conditions. And preparing to respond to all of those increasing factors and conditions intelligently is a very proactive exercise, right? It requires forethought, device research, browser testing, and often a bit of creativity. Because ultimately, we want to deliver sites that feel appropriate on any given device. If I could cite one thing that I've learned about well-built sites, both as a developer and as a user, it's that they just feel appropriate on whatever device you happen to use them on. So the more we meet our users' expectations and intuitions, the better services we provide. And to do that, our sites need to respond to a variety of things appropriately. So I'll give you some examples. Our user interfaces need to respond appropriately to a device's viewport size. And to adequately prepare our sites for a variety of viewport sizes, we can use that magical combination of fluid layout, fluid media, like images and video, and CSS media queries, what we've come to call responsive design, right? Of course, there's more to that. Along with viewport and screen size considerations, we need to pair the fidelity of the components within our pages with that which can be expected of a particular device's capabilities. So that means qualifying the application of the code and the features that we send to a device so that we don't break an already usable experience. Additionally, our interfaces need to be usable across a variety of input mechanisms. So keyboard, mouse, touch, assistive technology, screen readers, just to name a few. And most devices today offer more than one means of interacting with a page at a given time. Right? So in preparing our sites for different input mechanisms and different ways of interacting with our pages, we really need to be careful not to make presumptions about any of those modes being in play exclusively at any time. So those are some UI, UX related sort of ways that we prepare to respond. But before we can even consider any of those aspects, we need to first respond at all, right, to requests to our sites. So before accessibility, before usability, 60 frames per second animations, all these things we talk about a lot, we just need to deliver and deliver really quickly, right? So that'll be the focus of the rest of this talk. I'll show you how to think about rendering a page in a sort of progressive manner and some techniques that we can do to make our sites work that way and how those will sort of sustain and evolve over time. So let's start by talking about some delivery problems that we see today. Of the many advantages that we have of building on the web, I think the greatest of those is reach, right? The web broadens the reach of our services unlike any other technology. And given the varied means of accessing the web today, our sites can reach folks who access the web under very different conditions and circumstances than many of us do in this room day to day. And unfortunately, despite that distinct advantage that we have when we choose to build on the web, that advantage of reach, it's common to encounter, very common, to encounter sites that are built in really exclusive ways, inhibiting their reach, right? Sometimes that's due to assumptions that we make as designers or developers about the browsers that our users are using. Sometimes it's due to conveniences that we choose during the development process to make our jobs easier. We talk about how mobile and mobile devices change the way we design all of our websites. Suddenly, we needed to accommodate all these screen sizes, right? Well, along with those mobile devices, came other constraints too, like widely varying network speeds, right? Facebook has more users on 2G than 4G. Yet many of us web developers who are building every day are not experiencing 2G conditions, right? So that's sort of an interesting lesson, I think, that we in this room are kind of an edge case amongst our users. We're an exception. To work efficiently, we need really fast, reliable networks to stream enormous amounts of data. And when we're using the web or when we're testing our websites, we have access to some of the greatest, most capable internet accessing devices in existence, probably many of them. But while many of us work in relatively ideal conditions, we can't build for people just like us, right? And I think a really cool thing about our job as web developers and designers is that we have a lot of control over this, right? We can improve our users' experiences through better practices. And overall, I think we could be doing a better job. In performance talks, this chart tends to come up a lot. Right now, the average web page, not website, just web page, is over 2 megabytes. And that's a real problem, right? Kind of obviously a real problem. It's not the only thing that we need to care about with performance, but it's a real problem because data is costly, right? It's limited. It's common to have devices that are tied to monthly plans that have caps. It's common to browse the web on prepaid SIM cards. So there's a real cost to every byte that we download. And the good news about that is that there are pretty well-known ways that we can shrink the cost and the size of our sites so that they're cheaper to access. So some of those things, to start, we should be optimizing our files so they're lighter when they travel over the network, making our images smaller, subsetting our fonts, removing white space that's unmeaningful when we send text files, so minifying, it's called. HTML, JavaScript, CSS, these can all be minified when we send them over the network, and compressing for transfer, so using gzip, right, which is basically a way to compress the text asset on the server side, send it really small over the network, and then expand it in the browser. And most browsers today support that. Speaking of images, in addition to optimizing them and making them smaller, it often makes sense to offer the browser several different options for a particular image, maybe based on screen size, resolution of a device, or even network conditions. And fortunately, our community has been working really hard to come up with some standards that are now at least partially supported in most major browsers. So source set, which is an attribute we can put in our image elements now, to offer up various versions of an image and let the browser decide which one is most appropriate given what it knows about screen size, maybe network conditions, leave it up to the browser, versus picture, which is a container for an image element that has some instructions that are pretty specific, and they use media queries to say, here are some conditions under which this particular source should be the source of the image. So we have some nice tools there, and we should be using them. We should also work hard to reduce dependencies on large frameworks, right? Developer conveniences, Bootstrap, jQuery, at least the whole jQuery. In some cases, we can use tools to remove portions of those frameworks if we really need to use some of them. Sometimes we can create custom builds to, if we know which parts of a framework we need ahead of time. So there's good tooling for that. Sometimes we don't need these frameworks at all. Increasingly, we don't need these frameworks at all. So it's always nice to start from that perspective and add what we need throughout a project, right? And all these things help, but because they make our sites lighter and therefore cheaper. But I think from a performance perspective, and particularly from a perceived performance perspective, optimizing files is not really maybe our primary concern. It turns out that optimizations like that only get us so far. And only recently have we begun to acknowledge that reality. The size of our sites isn't always the biggest problem. The problem is kind of the speed of light. Ilya Grigorik, who works at Google and is amazing, you should read everything he writes. He had a great article about this. It's actually a few years old now. But he says, the web's performance problem is latency, not bandwidth. So what he's referring to is physical distance that our code needs to travel between the server and the browser, back and forth. A trip to the server and back takes time. It's measurable, sometimes a lot of time. The first issue we need to think about when we're talking about that round-trip latency is just connecting to the ISP, which, if you're on Wi-Fi, could take something like 150 milliseconds. Or if you're on a cell network, it could be that fast. It could be much, much slower, maybe a second or more. And that all depends on how recently your device has been in contact with a tower. So that's kind of the first leg of the latency problem, and also the last leg on a round trip. But the other one we need to worry about is physical distance, right? Our code is kind of moving around the world on fiber wire, right? And even at the speed of light, or nearly the speed of light anyway, that distance starts to add up, starts to take time. This is why CDNs matter, right? So after optimizing size, we still have to factor in these proximity delays. These round trips can take hundreds of milliseconds at best, usually over a second, though. And that's not even factoring in that the server takes time to process requests, too, right? So we want to make the most of a round trip, is what I'm getting at. And one of the ways we do that is sort of like this, like carrying groceries. Anyone ever done this? Like try to get everything in one trip from the car? Well, this is how you build a fast website, pretty much. Of course, if you're carrying groceries from the car, usually you can't fit everything, so you sort of have to prioritize, right? And then get the rest later, because you just want to get inside to the kitchen and make a sandwich immediately, and get the rest of the groceries later. They can wait. So to bring this metaphor back to how web pages load, because I do have a point here, it would kind of be like if you carried those ingredients into the house and you were starting to make your sandwich, and then you realized, forgot the mustard, right? So then you have to go all the way back to the car, get the mustard, come back, then you can finish making that sandwich and eat it. This is kind of like how web pages load, by default anyway. Because the first round trip to the server, when the browser makes a request to the server, HTML comes back. And the browser can show that to the user right away, but it won't until it gets the CSS and the JavaScript that it needs to show it properly, right? So that means another round trip. So it turns out that these sort of detours kind of happen with the standard ways that we reference assets, right? Links to style sheets, script elements. There are ways around this, but by default, these are all detours that get in the way, extra round trips until we can show the page. So this process of waiting until all these requests have gone to the server and back before rendering the page is known as render blocking. And it's kind of a good thing in some cases. We don't want to show a page until the CSS required for showing that page is available in the browser. Otherwise, you would see it unstyled, and then the CSS arrives later, and it pops into place. And that's not a very good experience. But the bad part of that is we don't want to make additional round trips before we can show the page. We already made a round trip. Let's see if we can make the most of it. So this is a case where optimizing assets can't really help us alone, right? We have to go further. So we have to avoid making render blocking requests that block our pages from being usable sooner. So fortunately, we have some nice tools that have come out in the last few years that can really help us analyze how our pages are loading and figure out how to optimize them and look at them and really deeply analyze, okay, this is where things are going wrong. This is a render blocking step we need to get rid of. One of those tools is webpagetest.org. And if you're not using this, I really, really recommend it. It's kind of become something I use like throughout the day. Every time I make a commit, I'll push a change. It'll actually get run through this tool, and we can analyze how that change affected our performance. What's nice about it, you can put a URL in, choose a browser or a device. These are real devices, and regions of the world that those devices live in, and it'll test your URL on that particular device and location and give you information about how it loaded. And some of that information starts to look like this when you see it in return. So we get this little table at the top, a nice little summary. There's some interesting numbers in here, like the total time it took to load everything, the total cost of the page, how heavy it was. We also have a particularly interesting number called start render. And that's the time at which it took to start displaying anything visual to the user. Now here I'm showing Filament Group's site run through this, and you can see at 300 milliseconds after you hit go in your browser, something is readable to the user. So that's extremely fast. It's really rare, actually. If you go through web page tests statistics, the average is something like 4.5 seconds for the top 10,000 sites on the web. So this is not common, but there are ways you can make almost any site start to get into this range. Those numbers say a lot, but another part of web page tests that I really like is this timeline tool, which breaks out your loading process into keyframes, 100 milliseconds, half a second, whatever you'd like, to really see how it progressively renders. So how do we get our site, Filament Group site, where I work, to render so quickly? Well, knowing a little bit about how our pages are transferred over the network can go a really long way. That first round trip to the server and back happens to carry back with it about 14 kilobytes of code, HTML in this case, compressed. So hypothetically, if we were able to fit our entire website in 14K, including CSS, JavaScript, all the things that are needed to render that page, then we'd pretty much be guaranteed that it would start rendering after one round trip. And that's sort of interesting, but most websites are a little heavier than 14 kilobytes, something like 2 megabytes. That's okay, though, because this is when we start to think, okay, well, let's try to prioritize some of that first delivery. What can we fit into that first 14K that's really meaningful so we can render something useful right away? Google has this tool called Page Speed Insights. This is another one I'd recommend. And they have all sorts of tips for speeding up a site. And one of them is related to this particular point. It says, identify and inline the CSS necessary for rendering above the fold content. The idea is that we need to avoid making requests for anything that we need to render the top portion of the page, right, above the fold, so to speak. Now, you might be thinking the fold. We were talking about the fold years ago. There is no fold, and that's true, right? The fold varies across devices. There's no consistent viewport height. But I don't think this recommendation needs to be controversial. They're just saying pages are viewed from the top to bottom, pretty much any browser you use. So they're telling us to prioritize the code necessary for rendering the top of the page before rendering lower portions in the page. And just a little bit. The rest will come in right away, just not holding up the user experience. Cool? I think that's okay. So how do we know which portion of the CSS is relevant to rendering the top of the page? Well, some folks at Google wrote a nice little article that answered this question. They built a bookmarklet that analyzes any given website, and it will identify the CSS rules and extract them that actually apply to elements in that top region of the page. And it's arbitrary, but we tend to go with a generous region, say 1200 by 900, and it depends on the project. We go wider than the widest breakpoint to capture all mobile first breakpoints up to the largest, and then a generous height. So in code, that ends up looking something like this. This is, if you can picture this being the original CSS file on the left, this is the critical rules of that file, which is a subset, a strict subset of that file. So these are just rules that apply to elements that happen to reside in the top portion of the page across breakpoints. Visually, I think it's a little more interesting. This is an article page on Filament's site. And on the left, it's rendered in its intended way. And this red line designates where we would consider, okay, we just want to analyze above that line. So that's our fold, so to speak, when we're processing this page. And you can see on the right, this page has only its critical CSS rules included. And the design just sort of falls away right below the red line. So we can see the tool is working, right? This isn't how we want the page to be used in the end, but delivering it this way first and then rendering the last, the second part later, is quite nice. It's usable sooner. So bookmarklets, kind of nice, but I wouldn't want to run a bookmarklet every time I'm updating a site or a template on a site. So for a production process, we use tools, command line tools usually, in our build process to extract the critical CSS and write them to files. One of those tools that we maintain is called Critical CSS. It runs on Node.js. It's a command line tool. Takes a little getting used to, a little learning curve at first, but becomes kind of natural to work with. And what we do is we have a configuration file that, this is the top of it anyway, where we have a series of unique templates on a site that we want to run this process on and extract the critical CSS. So any unique template, like a homepage, article template, services in this case. So you can see how this JSON sort of format, JavaScript objects, starts to describe how this tool should run. So first we'll run the homepage, and we want to output the critical CSS rules to that first file path. We want to analyze the full style sheet that applies to all pages on the site. That's all CSS. And then we have a URL for that actual template that will actually pull up in Phantom.js, which is WebKit, but you don't see it. It's just running on the command line, so it's called headless, and analyzes those rules and writes them to a file for each template. So that's where things get interesting, I think, because now we have this CSS file that pairs with each unique template on our site, and it represents the critical rules for that template. So to get our CSS off of that render blocking pattern that it started with, we want to pull that critical CSS file inline into each template, right? And that's instead of referencing the full style sheet, right? So we remove the full style sheet link, inline that. I'll show you how that looks. So when we're inlining CSS in HTML, we have the style element. This has been around forever. So two ways to bring CSS into the page. A link, well, there are a few ways, but two common ways. Link element, reference it externally. Style element, you can put the styles inline. Note, I'm talking about the style element, not the style attribute on, say, a paragraph element or something like that. So this is in the head of your page, and it'll come back with that first round trip request. Now, in production, you're probably not going to write out the styles like that. You would probably include them in a build process or a dynamic server-side include, something like that. So you can imagine each template includes the CSS rules that it needs. So that's only the critical CSS. We also need to load the full style sheet. And this is kind of new. There are ways to load a style sheet in a non-blocking manner with JavaScript, and I'll get to that in a minute. But recently, there's been a standard that's kind of been in discussion in the W3C, and is finally, I think Chrome's going to adopt it first. Link with a rel of preload. And this is it's a generic way to fetch an asset. So in this case, we're saying link rel equals preload and all CSS. And what this will do is just fetch that asset. It won't do anything with it. So in order to do something with it, like make it apply to the page as a style sheet, we need to listen for its onload event and do something with it. In this case, it's kind of easy. A style sheet just needs a rel attribute that equals style sheet instead of preload. So we just say onload, switch the rel attribute to style sheet. It'll apply to the page, right? So that's a forward-looking, standards-based way to do it. It is supported in no browsers yet. So we're going to need a polyfill, right, if we want to use this today. So let's jump over to JavaScript real quick and talk about the JavaScript that we inline in the head of the page. So in JavaScript, when we're inlining code, we have the script tag, right? It's also for referencing external code if we put a source attribute on it. But in this case, we can just pull some inline script into it. So if we're pulling script into the head of the page, it's got to be pretty important, right? Which brings us to the question, what JavaScript is critical, right? Ideally, we don't want any JavaScript to be critical. And really, it doesn't need to be critical to all devices. But what's nice about having a little JavaScript in the head of the page is it helps us gracefully enhance the user experience in more modern devices. So we can do things like test for features, load additional assets in ways that don't block rendering, and have some conditional logic in there to decide whether or not to load those at all, based on browser capabilities, things like that. So, speaking of functions that can help us load other assets, load CSS is one that we maintain, and it does what it says on the tin. You just call it by calling load CSS, and you pass a file path to a CSS file, and it'll load it and apply it to the page, right? So we can use this to start polyfilling the behavior of that link rel preload. But before we do that, we need to know if the browser supports that feature. So we need a feature test, right? And this is the one that is being thrown around currently in the discussion boards. So creates a link element, sets its rel attribute to preload in all caps, and then tests if it returns that value in lowercase. And the theory here is they're hoping to change the behavior of acceptable rel values to be case sensitive. So it would return that way if it supported the feature. Anyway, all we need to know here is we can run preload support. It'll return true or false. So now that we have those two functions, I've sort of paraphrased them here with ... on the inside. We can see how this all sort of comes together. So we start with the link rel preload. I've added an ID to it so I can just find it really easily. And then down here we say if preload support is false, then we call our load CSS function, get the href of that thing, and it polyfills the behavior, right? At the end, I've got a non-JavaScript version that will reference the full style sheet just in case. So that's our non-JavaScript fallback. So moving on from CSS loading, we also typically have a function in the head of the page that can help us load additional JavaScript. That way we're not inlining our DOM framework, jQuery, things like that, or the UI code that may or may not be needed on a particular device. So this kind of works like load CSS. Just call it load.js and pass a path to your full package of JavaScript. And we typically combine all of our scripts into one and make one request to them. So that would be enhancements.js would include jQuery or whatever DOM framework you may or may not be using, plus your carousel script, because of course you have a carousel, things like that. It's important to note that if you just wanted to load a JavaScript file without blocking the page, you can do that without running a JavaScript function. We have some standards-based attributes, async and defer, that you can apply to a script tag. That works great, and it's actually really broadly supported. The reason I don't use it all that often, especially when making sites that work across a variety of devices, is often I don't want to make the request in certain devices. I want to qualify it. So in this case, I'm doing something that has been referred to as cutting the mustard. If the browser cuts the mustard, load additional enhancements. In this case, I'll test for a couple of features, like query selector and add event listener. If those are supported, then I'll load my enhancements. If not, just leave the page alone. It works. So to bring that all together, if we step back and sort of look at the head of the page again, this is probably small towards the back of the room, but this is the most code I'll show throughout this talk. We start with our inline style. Then we have our link to the full style sheet. Then we have our script that says check if preload is supported. If not, we got to load it ourselves. And then, if the browser cuts the mustard, load additional enhancements. And then our no script link. So that's kind of like the entire head of the page when we build cross-browser sites these days. So all of that is nice because it moves our CSS and our JavaScript off that render blocking path. And it allows us to render the page in that first round trip. The problem is, if we're using custom fonts, all of that can sort of be not very useful, because the way that a lot of browsers handle loading custom fonts is to actually hide the text in the page while a custom font is loading that is going to style that text. So in the process of loading that font, the text is actually hidden from the user, rather than showing a fallback font. And that's unfortunate. So the standards groups are coming up with ideas or recommendations, I guess, for making this delay shorter, at least. And that's landed in a few browsers now. So Chrome, Firefox, they'll only wait 3 seconds before showing the default font. That's kind of nice. But something like iOS Safari right now, it is painful. I don't know if, show of hands, do you just sit here and look at blank pages a lot? Because I do. This is a site that has already been downloaded to the device, and I could start reading it, but there's a font that's still in the air, right? So it's not going to show me the page. And this took 40 seconds or something. So it's pretty painful. So recently, we've been taking an approach to sort of work around this problem by listening for when fonts have loaded with JavaScript and then applying them to the page. So styling our default fallback fonts really carefully so that their metrics line up pretty closely to how the custom font will render when it eventually loads. And that's important because we don't want a big reflow when the fonts come in. So it's kind of tricky, but I think it's worthwhile. And what's nice about listening for font loading with JavaScript is once the font loads, we can apply a class to the page and style fonts differently, depending on which font is in play. So that means we don't necessarily have to find a fallback font that matches metrics very, very closely on its own. We could style it with a different font size. And then once the custom font is there, it has a different font size. I'll show you how that looks. In CSS, it would just look like this. We have an H2, and it's styled with sans serif fallback font. It could be any fallback font that's widely installed. And then we have a class that we're opting into. So if you can imagine this class was added to the body or the HTML element, then we can use a descendant selector to say, OK, if that class is there, style the H2 with this particular font that we know is loaded now. The JavaScript for that is pretty nice and concise, I think. We're using Bram Stein of Typekit. He made a font face observer script. So we're listening for source sans pro to load, and we check it. It's kind of like this promise syntax. Once it's loaded, we're just adding a class name to the HTML element or the document element. And this is how this one little process affects the way Filament's homepage loads. So you can see if we weren't doing that with our custom fonts up top, the page is ready to render, the CSS is there, but since that font is still loading, it's blank all the way. This is on 3G, by the way, until 1.7 seconds. But with that workaround in play, it brings it down to 1.3, something like that. So it'll vary depending on the site. We only have one font in play, maybe two weights of one font. So some sites have a lot more than that. But at least you get usable text right away. Down the road, we'll be able to do this process with CSS alone. So this is a new feature that's coming. It's in the working groups being planned now, called font rendering in CSS. And it gives us a pretty rich API that is far too much to cover in this talk today. But this particular property of swap after 3 seconds kind of mimics the process that I just showed you with more JavaScript than we'd prefer to use. So looking ahead, we'd be able to just use CSS for that. So to wrap up these optimizations about rendering time, I wanted to show you a quick case study I did. Wired.com recently relaunched their site. It's responsive. It's really, really nice. The UI design is beautiful. Give you a look at that. This is one of their article templates. I think it'll play here. Yeah, you can see how it responds across breakpoints. And as you scroll down the page, you know, some things are fixed. It's really nice. Now, this site just launched, but I noticed right away that it seemed kind of painfully slow on my device when I was accessing it over my phone. So I ran it through web page test, Android, Chrome, 3G connection. And the first time you can get a usable rendered view is something like 12.5 seconds, right? And I don't mean to pick on Wired here because this is actually really common. This is not just Wired, right? So many sites. The Verge had an article this week. They declared bankruptcy on their performance. They're seeing this or worse, right? So this is a really common problem. But for example's sake, I wanted to see, OK, could I just take a random site that has these sort of bottlenecks, pull it down, start optimizing some things, and see if these these optimizations broadly apply to really any site. So I pulled down this site, put it on a test server, and got it running as is with this timing, or relatively similar, like half second off to the timing that they have on their live site. And then I started making some of the optimizations that I just showed. So inlining the critical CSS and loading the full style sheet asynchronously. Getting all the JavaScript off of that rendering path and loading it async, right? Advertising too, which was kind of tricky for that site. They have a lot of ads. Loading the fonts asynchronously and showing something usable from the start. And using those font events to listen for it and allow the custom fonts to come in. And the result of just doing those things was it brought the start rendering time down to 4 seconds. So we just cut 8.5 seconds or so of time waiting for something to happen on this device. And you can see somewhere, you can start to see it progressively reaching its intended state, but further down the timeline, it looks the same as it would have without these optimizations. It's just a progressive render. So you can see the comparison, all those blank keyframes, right? So what's sort of interesting, I think, about that case study is I never changed anything about the weight of the assets, right? And traditionally, we've thought of page weight to be really directly related to how fast a site is usable. And that's true in a lot of aspects, but it's also, it's somewhat tangentially related too. And there are reasons that the weight of a page is costly, and there may be not necessarily the same reasons that rendering time is slow, right? So they're sort of related, but we can do things. Even if you have a heavy site, you can optimize it to render really quickly. So that's pretty neat, I think. This is a 9 megabyte website, by the way, or 9 megabyte page. And that didn't change. So, looking ahead, what I showed today were a lot of workarounds, right? Performance is often about making workarounds. And if you're already building sites that perform well, you're probably making some workarounds of your own, right? Concatenating files, making sprites out of images, and then minifying, all these things just for delivery purposes, right? And the things I just showed are workarounds just the same. They're not involved in the process of when we're editing our files, but after we hit save, then the tools kick in and start churning through these files and getting them ready for sending over the network. But they are workarounds, right? So will they be needed long term? Ideally, no, right? So fortunately, HTTP, the specification, has a new version, version 2, that's actually going to make a lot of what I told you completely unnecessary. So I'm sorry. Ilya, again, has a nice article talking about this feature of HTTP 2 called server push. And he basically says anytime you've inlined a resource, like, say, inlining CSS into the head of your page, you're mimicking server push. This is a feature of HTTP 2, which is really cool. At a basic level, you make a request for the home page of a website, and the server knows that when you need that page, you also need these series of assets to come with it. You need this CSS file, you need this JavaScript file, whatever. It can send all that back with that round trip. So it basically negates the need to inline anything, which is great, because it's better for caching, better for all sorts of reasons. So inlining is one of those things that version 2 will help a lot with. Concatenating files, combining them into one request, may be an anti-pattern once we get HTTP 2 really standardized across browsers and across the servers that we're working with. Sharding the requests that we make to domains. Currently, browsers have limitations about how many active requests they can have on a particular domain, so we've been working around that by setting up all these CDNs with crazy subdomain names, so we can try to trick the browser into fetching them from all sorts of places and get them down quicker. We won't need to do that anymore. Spriting, if you're still doing that, you don't need to anymore. we're kind of seeing less of image sprites in our workflows at Filament anyway. Kind of moved to SVG, things like that for icons. So HTTP2, it's coming. But of course, support is not going to reach older browsers that never understood it in the first place, right? So this is a forward-looking spec. So IE10 and older, no HTTP2. So it's going to be a tiered process getting this worked out, and we're going to have to figure out ways to have both in play at once and keep serving people who are still on these devices, right, in these browsers. So, in the words of the HTTP2 spec writer, this will not happen overnight. But it's on the horizon, and I think it's interesting. It's something to keep in mind as we're making these optimizations. And to me, it's sort of just another aspect of planning to respond appropriately, right? It's something we need to think about ahead of time. It's kind of like progressive enhancement in that way. We've got 1 and 2 going on at the same time. So, I covered a lot today in relatively short time. I'll give you a quick recap. To deliver responsibly requires a lot of preparation and forethought, right? So we need to be liberal in the input in what we accept from user interaction, and really conservative in the features that we apply. Really careful about that. Most of all, I think we need to remember that we can build really beautiful, complex user interfaces without excluding anyone, without breaking accessibility. And it's harder that way, but it's really our job, right? I mean, that's the interesting part of our job. That's what excites me anyway. So, that's all for today. My name is Scott. That's my book. I've got a couple copies if you want to see me afterwards. Be happy to hand them out. Thanks so much for listening.